Ever wondered how subnetting works in the cyber field? It's one of those invisible gears that keep our digital world running smoothly. An integral part of network design, subnetting is a technique that divides a network into smaller, more manageable parts, or subnets. It's like organizing a large team into smaller groups, each with a specific role to improve efficiency and security. Subnetting is crucial in the cyber field. It enhances network performance, reduces congestion, and most importantly, it adds an additional layer of security. By isolating network traffic, it helps prevent unauthorized access and contain potential threats. Over the next several minutes, we will explore both classful and classless subnetting, two methods used to divide a network into subnets. Each has its own unique characteristics and uses, and understanding them is key to mastering network design. So, buckle up for a deep dive into the world of subnetting. First up, let's get to grips with classful subnetting. Classful subnetting is a method of dividing IP networks into smaller networks called subnets. The term classful refers to the fact that this method is based on the original classful network design, which categorizes IP addresses into three classes, A, B, and C. In Class A, the first 8 bits, or the first octet, are used to identify the network portion, leaving the remaining 3 octets for the host addresses. This gives us a whopping 16,777,214 addresses per network, ideal for large networks. Class B, on the other hand, uses the first 16 bits, or the first 2 octets for the network portion, leaving the remaining 2 octets for host addresses. This gives us 65,534 addresses per network, suitable for medium-sized networks. Finally, in Class C, the first 24 bits, or the first 3 octets, are used to identify the network portion, leaving just 1 octet for host addresses. This gives us 254 addresses per network, perfect for small networks. One thing to note is that in classful subnetting, the division between the network and host portions is fixed based on the IP address class. This means that all subnets in a network must be the same size, which can lead to inefficiencies. For example, if you have a Class B network but only need a few hundred addresses, you'd be left with thousands of unused addresses. So, classful subnetting, while simple, can be wasteful. It was the initial way subnetting was done, but as the internet grew, it was clear that a more flexible system was needed. This led to the development of classless subnetting, which we'll explore in the next scene. Now that we've mastered classful subnetting, it's time to move on to classless. Scene script. Next on our journey is classless subnetting. Imagine you're planning a party and you've got a big cake. Classful subnetting is like cutting the cake into equal slices, regardless of how many guests you have. Some might get more than they can eat, while others might not get any at all. That's where classless subnetting comes to the rescue. It's like cutting the cake based on how hungry each guest is, ensuring no one goes hungry and no cake is wasted. Classless subnetting, also known as CIDR, which stands for classless interdomain routing, is a more flexible and efficient way to allocate IP addresses. Unlike classful subnetting that relies on predefined classes, classless subnetting allows you to divide your network based on your needs. It's like having a tailor-made suit cut and stitched exactly to your measurements. So, how does it work? Classless subnetting uses a method called variable length subnet masking, or VLSM. VLSM lets you choose exactly how many hosts you want on each subnet by changing the subnet mask. It's like having a magic wand that lets you divide your network into various sizes. Let's say you have a network, and it needs to be divided into subnets of different sizes, one for 50 devices, another for 25, and a third for just 5. With classful subnetting, this would be impossible. But with classless subnetting and VLSM, it's a piece of cake. Classless subnetting is a boon in the world of networking. It helps make the most out of IP address space, reduces waste, and allows for more precise control over network management. In the realm of cybersecurity, classless subnetting plays a pivotal role too. By allowing for precise network segmentation, it enhances security by isolating different parts of the network, thus limiting the spread of potential threats. With classless subnetting under our belt, we're ready to summarize our key points. So, what have we learned about subnetting? Subnetting is a powerful technique that allows network administrators to divide an IP network into smaller, more manageable parts, or subnets. These subnets help control and reduce network traffic, improve network performance, and simplify management tasks. Now let's revisit classful and classless subnetting. Classful subnetting, the older method, is based on the original classes of IP addresses, class A, B, and C. It's straightforward but lacks flexibility. It often leads to wasted IP addresses, which is not ideal in today's digital world where IP addresses are a precious resource. On the other hand, classless subnetting, also known as CIDR, is a more modern approach. It discards the traditional class distinctions and allows for flexible subnet sizes. This flexibility maximizes IP address usage and is, therefore, more efficient and effective in managing network resources. In the cyber field, subnetting plays a crucial role. It is used to segment networks, which not only improves performance but also enhances security. By isolating different parts of the network, we can apply different security measures and policies. This reduces the risk of a cyber attack spreading across the entire network, providing an additional layer of protection. Subnetting might seem complex at first, but with a little practice, it becomes a powerful tool in network management. Whether you're a seasoned network engineer or a beginner in the field, understanding subnetting is a crucial skill to master. Subnetting, whether classful or classless, forms the backbone of network management. It's more than just splitting networks. It's about efficient organization, improved security, and optimized data flow. Its relevance echoes in every corner of the cyber field, influencing how we connect, communicate, and protect our digital world. This is just the tip of the iceberg. There's a whole ocean of advanced networking topics awaiting your exploration. Remember, in the world of networking, knowledge is power. Keep learning, keep exploring.